Hey guys, it's your favorite chemistry teacher. I'm going to start posting some videos of the different topics that you're going to need to review in your Barron's Review book. Basically, I'm going to just kind of like write myself some notes on a piece of paper, and this paper you should print so that you can follow along with me. I'm going to talk through the piece of paper. I left some blanks if I need to go over equations or writing electron configurations, things like that. And remember, this is like very homemade, so these videos are not going to be the best quality. Okay, so I hope you all printed this sheet. There should be 2 pages for topic 1. And we're going to go over scientists, some equations you need to know, quantum numbers, and writing electron configurations, which you should be good at. So I'm just going to kind of start talking about some scientists, and then I will move the camera so that you can see me do some equations. The first scientist you should know is Dalton. So Dalton is the one that gets a lot of credit for the modern atomic theory. He was like the first guy in modern times that did a bunch of experiments and then found that he combined different elements and found that it made compounds in whole number ratios. One of the things he found that was actually proven false is that all atoms are exactly the same. So like all carbon atoms would be exactly the same. You guys know that's not true because isotopes are carbon atoms that have the same atomic number, different atomic mass, so their neutrons are different. So he's the first guy, and then from him we have Thomson. So Thomson discovered the electron. He did the cathode ray tube experiment, where he had like a vacuum chamber and he passed through cathode rays, and there was a magnetic field. And if this is the positive field and that's negative, he found that the cathode rays traveled through and always attracted towards the positive field, which then he concluded was the cathode ray was made of negative particles, which he called electrons. Okay, number 3, Millikan. Millikan did the oil drop experiment. And from that experiment, he found the exact charge of an electron. I wouldn't worry too much about how he found it, although if you do want to read about that, it's in your review book. Okay, number 4, we have Rutherford. So Rutherford, as you all know, did the gold foil experiment. So shot alpha particles at gold foil, 90% went through, 10% bounced back. From that, he concluded that the atom has a dense positive center and is made of mostly empty space. After Rutherford, we have Planck. It's out of order on your sheet. Planck was the one that came up with quanta, which are just packets of energy. So when the electrons are moving, they're not moving in a continuous continuous spectrum of energy like you might think about. They're moving in little packets or small chunks of energy. So it's like kind of if you're walking up a ladder, if you're an electron, the electron has to go from rung to rung. It can't just go in between or you'll slip through the rung. So Planck did quanta. After Planck we have Bohr, and Bohr studied hydrogen line spectra, and found that electrons travel in orbits, which are circular paths with specific energy levels. Bohr's model is really important. The problem is it only worked for hydrogen. After Bohr, we have de Broglie, and de Broglie was talking about the dual nature of matter. So he said that matter acts as particles, which we know has like mass and volume, that kind of thing, and can also act in waves. So if you have an electron is actually traveling in waves. Same thing if you have anything macroscopic, it's just their wavelength is way too small for us to see. The dual nature of matter, this is in a multiple choice question you guys have seen a lot. The dual nature of matter explains electron diffraction. So when you look through, if you remember in honors when you wore those funny glasses and you look through and you can see the different colors, that's showing the wave nature of matter. Okay, we have Heisenberg. Heisenberg did the uncertainty principle. He said you can't know both position and momentum of an electron at the same time. So once you pinpoint a position, it's already started moving, so you can't figure out how fast it was going. Okay, and then we have Schrödinger, who has the most modern model of our atom. He said that electrons travel in orbitals, which are regions of probability. So basically the location of an electron is based on energetic probabilities. Okay, so that brings us to our first set of equations. So I'm just going to show you a peek in your reference table. This is in a Princeton Review book, but that's what your reference table looks like. There, the atomic structure equations. There are atomic structure constants and description of the symbols. Okay, so let's go through and do our first calculation. Okay, so I'm going to hold this. I'm not sure if that's going to be the best, but whoa, sorry, the mothership is signaling. Okay, so we have our three equations. We have the speed of light equals wavelength times frequency. Speed of light is measured in meters per second, so that means wavelength needs to be measured in meters, and frequency is 1 over seconds, or seconds to the minus 1. We have energy equals Planck's constant times frequency. Planck's constant is in your reference table. So is the value of the speed of light, so don't worry about memorizing those. This is the important equation you need to know that will help determine energy changes. So we have E equals negative 2.178 times 10 to the negative 18th over n squared, where n, this, is equal to the energy level. So if you're going in level 1, it's 1 squared. Okay, so let's look at this equation, or this problem. So determine the energy transition when an electron moves from n equals 6 to n equals 2. Is energy absorbed or released? So in this one, we're trying to find the change in energy. And the change in energy is going to be equal to E final minus E initial, EF minus EI. So first thing you need to do is decide what transition is initial and which one is final. So we have from n equals 6 to n equals 2. So that means that this is your initial and this is your final. So you can set it up like, my dog's about to bark, so sorry if you hear something loud. E equals negative 2. Hey, lady.